It's going to have a specific reading on the ohm meter. I'll take our meter and put it to about the 20,000 ohm scale or the 20K scale, and connect one lead to the body and the other one to the terminal, and we'll get a specific reading. In this case, about 1,930 or so ohms.
Sure.
Now remember, this is a cool one. This engine is quite warm. It's been running. So to illustrate the difference between a cool one and a warm one, we simply take and connect the black lead to a good ground, the positive lead to the sensor terminal, and here we can see we're at about 460 or 470 ohms. Quite a difference.
Yeah, there certainly is. Now, when you actually perform this test on your vehicle, you're going to be running the engine. You connect your meter up. You're going to run the engine for 2 minutes, and you're going to look for a 200 ohm difference within that 2-minute period. For sake of illustration, we did it this way. If you don't find any change, boom, that's your problem. Replace the coolant temp sensor, and you're on the road again. If you do find a change, your coolant temp sensor is okay, and then you've got to get back in the book and do a little bit of work and go to your actual trouble code chart and follow your diagnostic chart out to find the problem. In this case, you'd probably find an open coolant sensor circuit wire or something in the ECM.
To test a coolant temperature sensor on the vehicle, do the following. Attach the red lead of the digital volt ohm meter to the coolant temperature sensor terminal. Attach the black lead to a good engine ground. Observe and record the meter readings with the engine at ambient temperature. Start and run the engine for 2 minutes. Observe and compare the meter reading to the first reading. Look for a minimum 200 ohm difference, indicating a good sensor. If the sensor tests okay, locate and follow the diagnostic chart in the proper service manual.
To replace your engine coolant temperature sensor, the tools you will need include a standard or metric wrench set, a hex wrench set, a regular blade screwdriver, liquid pipe thread sealant, a gallon of antifreeze, a large drain pan, and the correct coolant temperature sensor for your vehicle. Whenever working on your vehicle, always start repairs after the engine has cooled down. This will prevent personal injury due to hot engine coolant. The first step whenever working on the electrical system is to turn off all the accessories, including the ignition key. Then, disconnect the negative battery cable. This will keep spike voltages from damaging other components and will prevent the electric cooling fan from engaging during repairs. Before disconnecting the negative battery cable, be sure to write down any pre-programmed electronic radio stations on a piece of paper. This will allow quicker reprogramming when repairs are completed. On most vehicles, the engine coolant temperature sensor will be located either in the coolant passages of the intake manifold or near the thermostat housing. Next, open the radiator drain and lower the level of the fluid in the system. This will prevent coolant from spilling out onto the engine after the sensor has been removed. Make sure you have a drain pan to catch the old coolant. Then remove the radiator cap. On many late model vehicles, a bleeder plug must also be removed from the thermostat housing. Release the locking tab on the electrical connector and remove the electrical connector from the engine coolant temp sensor. Using a wrench or the appropriate socket, remove the old sensor. Compare the old sensor to the new one to be sure of correct replacement. Inspect the old coolant temperature sensor tip for scaling and deposits. If scaling is evident, we strongly recommend the cooling system be flushed and the engine coolant also be replaced to prevent scaling and deposits from forming on the new sensor. If the new temperature coolant sensor's threads are coated with a pipe sealant to prevent coolant leakage, no additional sealer is necessary. Install the new sensor and tighten it securely. Before reconnecting the electrical connector, inspect the connector for signs of damage and for wetness. If the connector is wet from engine coolant, inspect the entire wire for corrosion and replace as necessary. Reconnect the electrical connector to the new sensor, making sure the locking tab is secure. Add a new coolant mixture of 50% water, 50% antifreeze to the radiator until it reaches the radiator cap seat. We recommend you do not reuse the old engine coolant that was removed. On vehicles where a threaded bleeder plug was removed, add coolant into the radiator until it reaches the bottom of the bleeder plug hole. With sealer on the threads, reinstall the bleeder plug in the hole and tighten it securely. After installing the bleeder plug, continue to fill the radiator until it reaches the radiator cap seat. Reinstall the radiator cap. On vehicles with a coolant reservoir, fill with new engine coolant until the level is between the minimum and maximum marks. Reconnect the negative battery cable. Start the engine and run until normal operating temperature is reached. With the engine idling, add coolant to the reservoir as needed. And lastly, reprogram the electronic radio stations if so equipped.
To replace your coolant temperature sensor, follow these steps. Turn off all accessories on the vehicle, then turn the ignition key to the off position. Locate the coolant temperature sensor found in the engine block. Drain the engine coolant from the radiator. Disconnect the coolant sensor electrical lead. Remove the coolant temperature sensor from the vehicle. Once removed, inspect the sensor tip for scaling or deposits. If any are found, flush and refill the cooling system. Compare the old and new sensors to ensure a proper fit. Install the new sensor using a liquid pipe thread sealant on the threads. Install the electrical connector and reconnect to the new sensor. Refill the cooling system with a new 50-50 mixture of water and antifreeze.
Okay, Jim, for sake of example, what I've got again is a late model GM vehicle. I got a sudden drop in fuel economy, sluggish performance. So what I went and did is I pulled the codes out of the ECM. What I found was a code 33. Well, I referred to the manual on that vehicle. Code 33 told me I've got a map sensor circuit problem. Where do we go from there?
Well, that really doesn't surprise me because a map sensor can cause a drastic decrease in mileage and some sluggish performance. But I think what we'll have to do is test this. I would suggest a quick 2-minute test to verify that code before we go any further.
Okay.
Now what we're going to need is a vacuum pump to supply the vacuum that the intake manifold would normally supply. We're going to need a voltmeter, and we're going to need some way to make it run. So I brought along a special tester for that. This is our universal tester again with the correct end on it for plugging into map sensors for this type of testing.
Okay.
So I'll get that plugged in, and perhaps you'd like to do the vacuum gauge while I get the voltmeter turned on.
What your map sensor does is it signals the computer as to how much load is on the engine, and therefore the computer adjusts the fuel mixture and the ignition timing to match that load.
Now what we want to do is watch the voltmeter here. As you apply vacuum, the voltage should change. Okay. And I suggest going to about 15 or 16 inches of vacuum and holding when you get there.
Okay, this is similar to our throttle position sensor test. You want to watch to see if the voltage changes evenly, and in our case it does, and I'm at 15 inches of vacuum, and it holds vacuum.
Right. After you're satisfied that the part doesn't leak at all, go ahead and release the vacuum, and the voltage should go back down to somewhere near where it was before.
And it does. Now, this happens to be a map sensor off from a GM vehicle, and it's operating fine. So that is not our problem.
That's right. And since it's not our problem, on the vehicle you spoke about, we would have to go to our book that talks about diagnostic trees and trouble codes and find the map sensor diagnostic tree and just follow the step-by-step procedures for that map sensor. And what you'll find is that you either have a bad vacuum hose or an electrical connection. It could be an ECM again, but somewhere in there is where your problem lies.
Okay, so we know replacing the